All right, so today we are looking at the last new thing before our test, which is Friday. Okay, so our test is this Friday. And today it's about solving compound inequalities. All right, so first thing to think about is when you think about a compound, what are you thinking of?
H2O.
Okay, so two words that come together. You could be thinking of a science compound. That's absolutely where it's multiple elements together, right? Compound inequalities means you're going to have two inequalities. All right, so that's what it's talking about for us. So that means when you go to graph it, two things can happen. All right, you're going to have 2 points on your inequality, okay, and then they're either going to connect or they're going to go in opposite directions. Okay, so those are all things that can happen. So let's start by looking at this second slide here. And this slide is really just going to give you some ideas in words and ways of showing it and representing it. Okay? So, in words, if somebody said they want you to represent all real numbers greater than 2 and less than 6. That's an example of a compound inequality because it's not just one thing happening, it is two. So, when they say greater than 2, you can easily see that right here. Well, that just means x is larger than 2. And then here's the big thing. They use the word and x is less than 6. So then you draw another one, x is less than 6. Okay? The word and means the inequalities fit together. All right? It's going to connect the 2 points. All right? That's what we call an and. The other one's going to be or that you see down here. All right? But when it's and, that's where your x's would fit together. So if we were to write these two inequalities together, you would say 2 is less than x, but x is less than 6. So you list them separately, but then they can also be written together. Okay? That's the biggest thing to check out and see. Okay? Now, look over here. All right? As you're doing this, okay, your inequalities can then be what? Graphed together, right? You use the two numbers as your dots. So you've got 2 and you've got 6. So that's where they get connected. There's no line underneath them, so they have open. But then the answer that would make this correct is anything that falls between them. So that's why you connect them. Any questions there? Okay. Now, it can work the same, and it could just be greater than or equal to, or less than or equal to. And again, the only thing that changes is instead of having open dots, you would have closed dots. All right? Any questions on the and ones? Okay? Now, the other way you could see compounds written is it could say all real numbers less than 2 or greater than 6. So now when you look at this, you've got x is less than the number 2 or x is greater than the number 6. If you went to write these and try and put them together, it would not work because you'd end up with x is less than 2, so the x would be on the outside, but then x is greater than 6. You'd have two different x's in different places. You can't do it. The word or tells you they go in opposite directions. So as you look at here, x is less than 2, so it means everything smaller than 2, or x is bigger than 6, everything greater than 6. Does everybody see how that fits? Okay? And then the last one here is just like before, you could use or equal to, and the only thing it does is it closes off your dots because it adds the answers of those numbers. All right? Questions? Nothing. All right. Well then, let's go ahead. Anytime we've seen an inequality written, right? What have you noticed? Go on and look at one of these examples. So, I'm very nice and mean. I start you off with a word problem. Let's talk through it and figure it out. Okay? What it says is the pH level of a popular shampoo is between 6 and 6.5 inclusively. Okay? So it says it is what? between 6 and 6.5 inclusive. Okay? Write a compound inequality to show the pH levels of the shampoo and then graph it. Okay? Well, it's easy enough here. It's just making sure we understand. If the numbers have to be between 6 and 6.5, what does that mean? I'm going to graph it first because I think that'll make better sense to y'all. Okay? So if we were to graph it, right? We know we're going to have the number 6 and we're going to have the number 6.5. Okay? Well, it's got to be between those two. Okay? Now, the word that you might not know here is inclusive. Inclusive means to include. So all that means is that it can be 6 and it can be 6.5. How you denote that on the graph is you color it in. Now, if it says it's got to be between those two, am I going to connect these two dots or am I going to have them going in opposite directions? We are going to connect them. That would be 100% correct. So, how the graph looks is simply this. Your answer that would make it true, or that would have to happen anytime you looked at the pH level of the shampoo, is it would be between 6 and 6.5. Okay? Now, if you were to write that as an actual inequality, you know you're going to have 6 on one end, you're going to have 6.5 on the other end. Right? Now, what's got to go in between them because it's an inequality? An x. Now, we already talked about it when the two things connect. That's an and, so you can write it as 1. That just means x has to be bigger than the bottom one, but smaller than the top. However, inclusive tells us what? The dots are closed. So what kind of inequalities will go here? Yeah, so it's 6 is less than or equal to x, and x is less than or equal to 6.5, giving you your final inequality. Questions? Okay. Back. Let's look at one that is actually just a problem. This is something that we've been used to working. Okay, now, here it says solve the compound inequality and graph the solutions. Okay, here's the big thing I need you to notice. How many inequalities are there? 2. Now, anytime we've seen, and I know we haven't spent a lot of time, but I'm just going to flat, variable is always by itself. So in the middle right here, is the x by itself? No, it is not. How do we get it to be by itself? Subtract 1. Good. Now, here's the part that's different. Here's the part you need to understand. When you subtract 1, how do you decide which one you subtract it from outside the inequalities? Because before, we subtracted it from one side, we subtracted it from the other side. Well, now there's 2 other sides. How do you decide which one gets a subtracted 1? Say it again. Yeah, that's exactly correct. Look at you, O. Yeah. So, when you subtract it from the middle, you don't just pick one or the other. You've got to do it to both. So, if you subtract 1 in the middle, you subtract 1 on the left, and you subtract 1 on the right. Okay? So, looking at that, now it's going through and figuring out what's going to happen. Well, negative 5 minus 1 becomes a negative 6. You don't do anything to your inequality. That cancels out and it leaves you with an x. And then up here, 2 minus 1 is 1. Guess what we just found? Our new inequality. Negative 6 is less than x, which is less than 1. Now, step 2 says to do what? Graph it. How many dots am I going to have? 2. Okay? Guys, when you do compounds, just list the numbers. I'm good if you just list the numbers. So you've got the number -6 down here, and you've got the number 1. What kind of dots are going to go with these? Open. Now, let me ask you something. Do you think eventually we're going to get to where you could have one open and one closed? Yeah, that's eventually going to happen. So be on the lookout for that. I think it happens in your homework. Okay? Now, since these two, the X is in the middle of the numbers, right? That means what do we do to these dots? We connect them. So that would be your graph. All right. Any questions?
You connect them again.
Okay. How do you know you connect them? When it's written like this, okay, you know you connect them because your X is in between the two numbers. If it's written as two separate inequalities and they use the word or, you do not connect them. They go in opposite ways. In word problems, they would use the word in between or the word and, things that tie them together. Okay? What's up?
How do you know?
All right, now, so here's a perfect example. All right, it says solve the compound inequality and graph the solutions. Okay, so notice here they give you two different scenarios, right? They give you 8 is less than 3x minus 1, and they give you 3x minus 1 is less than or equal to 11. Well, before you can do any of this, you've got to solve each one individually. All right, so yeah, we got to solve these individually. So I'm going to start over here with the first one. I've got 8 is less than 3x minus 1. Well, step 1 is I want to add a 1 to each side. So 8 plus 1 is 9, which is less than 3x. Okay, now, what do you think you need to do to get x by itself? Divide it by 3. So 3 is less than x. All right, the second one, same idea, except I want to start by adding 1 to both sides. 3x is less than or equal to 12. Divide both sides by 3, and you end up with x is less than or equal to 4. Now, the thing that I'm going to do, and I'm going to write this here, is remember, this had the word what between it? And. So, what you can see right here is when it is and, you can actually take these two and fit them into one inequality. Sometimes you might have to move them around so that they match up. But notice here, we've got 3 is less than x, and x is less than or equal to 4. So the x's would actually just go in the middle in the same spot. Are y'all with me? Okay. So as I'm going to write this, that means I'm going to end up with 3 is less than x, but x is also what? Less than or equal to 4. Those variables are the same, so it's the same thing. You just got to write it once. So that means it is less than or equal to 4. Huh. It's like I'm a mind reader. Okay. So right here, you can clearly see it. All right. You've got one that is just less than. The other one is greater than or equal to or less than or equal to, however you want to read it. So when you go to graph them, that means you're going to have one dot that is open and one dot that is closed. You've got the number 3. You've got the number 4. Over the number 3, your inequality does not have the or equal to, so it is open. However, the one with 4 does have the or equal to, so it is going to be closed. It uses the word and the x is between the two. So there you have it. Anybody got any questions on that? Okay. All right, now let's get into the next phase, okay? The big difference you should notice is it uses the word what? Or, okay? Now, nothing changes from the fact these are two separate equations. So what do we have to do to them? Solve them, right? So, as you go to solve, first thing you do is try and get t by itself. I'm working on just this equation over here, okay? I want to get t by itself. So, the first thing I do is subtract 8. Once that happens, t is greater than or equal to -1. Okay? Then, you do the same thing over here. You want to get t by itself, so I need to subtract 8. Once that happens, I get t is less than -6. Okay? So, looking at that, all right, now I've got these two different things, but the big thing to remember is what was used. Or. Now, I'm going to show you why you can't write these together. Are y'all okay with that? Okay? So, as I look at this first one, if I were to try and write it like I was, I would have -1 is less than or equal to t. But then, what does this one say? T is less than or equal to -6. Well, look how that would have to write. That would then have to be, well, okay, well, I've got to do, I've got to, t is less than -6, but then when I do that, I'm going to show you the big issue. What goes right here? Yeah, the word or. Do you see how it doesn't fit together? My two variables don't end up in the same area. So that's why I'd have to use the word or, because you cannot physically write it as one long inequality. Okay? So that's why I do not want that there. Okay, so I'm just going to scribble that out. That was just an example of why you can't do it. So now we know that, hey, this is actually our final answer. So then you've just got to take it and do your inequality. You know you're going to have two numbers. Those numbers are -6 and -1. Let me stop and remind you of something. If you write -1 and then -6 over here, you would lose points. Y'all with me? Because that's not accurate. That's not true. All right? You got to write it where it has math integrity. Okay? Then, as I look with my -6, it is an open dot. And then with my -1, it is a closed dot. Now, I've probably programmed into you that it uses the word or. It's got to go in opposite directions. But let's just look at each one and show you that if you forget that, you can still figure it out. Okay? Because if you view this first one, t is greater than or equal to -1. Well, if something is greater than, does it go to the right or to the left? To the right. Bigger is always to the right. If it were smaller, like t is less than -6, it's going to go to the left. When things are bigger, they go to the right. When they are smaller, they go to the left. So even if you have a complete brain fart and can't remember that or goes in opposite directions, you could still figure it out. We good? We good? Good. You start yelling. Okay? All right. Do you think y'all can try one? Okay. I'm going to pause this and let y'all try it, and then we'll go over it. Ready, set, go. All right. So, y'all got a chance to work it out. Let me talk through it. I'm going to just go a little bit quicker, and we'll see. So, again, I see that it is an or, so that helps me out. I know with this first one, I want to divide each side by 4. Now, this brings me to a point, and I'm just going to talk through it. It didn't have to happen here. What do you think we would do if we had to divide or multiply by a negative? Switch how many? Okay, well, 1, but if you were doing a compound inequality, you would switch both. So if you end up switching 1, you should also end up switching the other one some way, somehow, all right? So with a or statement, both of them would end up flipping on their own, but with an and statement, if you divided both by a -2, you'd have to flip them both. All right, and we should see an example like that coming up in a little bit. All right, so once you solve this inequality, you should get x is less than or equal to 5, or x is greater than 7. Okay, so when you come to graph this, you know you're going to have them at 5 and at 7. You have a closed dot at 5. You have an open dot at 7. What it tells you, x is less than or equal to 5. So that means it's everything smaller than 5. So that goes to the left. And x is greater than 7. So it's everything that is bigger than 7. So that would be to the right. Okay. Look at that. All right, now, here is the last little thing to look at, going in the opposite direction, okay? So far we've been given a word problem, and we had to write them. We've been given the inequality, we've had to simplify and graph them. Now we're going to be given the graph, and you've got to write the inequality. So, here when I look at this, the first thing I notice, the dots and the arrows go in opposite directions. What should that automatically tell me? Or. You guys are so smart. So then it's just writing the inequality for each side. What number am I going to use over here? I'm sorry. What number am I going to use on the left-hand side? 8. -8. Good. So I know I'm going to have my variable x, and I know I'm going to have -8. Now it's deciding what does the inequality look like. Well, it's going to be less than. You are correct. But then is the dot open or closed? Closed. So it's going to have the line underneath it. So right there it's saying x is less than or equal to 8. Or what about on the other side? What's the number I'm using? 0. Okay. Now, it is not closed, so you know it's either going to be greater than or less than. Well, what is it saying? All the answers go to the right, so it's everything bigger, so x has to be greater. Bam. Any questions on that? That's just kind of working backwards and being able to apply what you graph from seeing it. Okay? Last little slide to get through. This is obviously going to be an and one, right? When it is and, in my opinion, it's easier to just write it straight as the inequality and not go this and this. Because you know it's going to take the look of the number on the left, x in the middle, and the number on the right. Uh-oh. Now, I gave you a cheat. This is the first time this has happened. You've got 4 and 6, but it's the number in the middle. It's okay to round. What number goes between 4 and 6? 5. I did give it to you there, but just so y'all didn't freak out. Okay? Now, this is easy enough, right? Y'all can look at this and probably figure out which way the signs go, correct? You know that -2 is going to be the smallest, so x has got to be bigger than that. But then x has to be smaller than 5, okay? But if you had a brain fart, let me talk you through how you could have figured this out. You could have said, hey, all right, well, -2, but the line is bigger than -2, so x has got to be greater than -2. Oh, over here you've got 5, but the line's to the left of 5. Oh, so that means x has to be less than 5. So you can still talk it out and figure it out, but it's also one that it kind of naturally fits together and really helps you out, okay? All right, so what I'm going to do is give you your homework, and that's going to be it.